Hi, my name is Jules Marshall,
And I'm Blumenberg.
and we will be presenting our study investigating thermal plasticity in the winter ants, P. imparis, at the Westchester Undergrad Research Conference. We are interested in how animals adjust their thermal physiology in response to the changing environment. We focus on the winter ants in this experiment because the species is active at much lower temperatures than other ants. Specifically, we're interested in the winter ants' capacity to adjust their thermal tolerance across their active season, which is from fall to spring. We hypothesize that the thermal tolerance will drop from fall to winter and rise from winter to spring. To test our hypothesis, we used baited traps to collect the winter ants on our CMSB campus. Once we collected the ants, we tested their thermal maximum using a digital dry bath. The starting temperature was 35 degrees Celsius, and that temperature was increased by 2 degrees every 10 minutes. And at the 10-minute marker, we looked to see what ants stopped moving, and we recorded it as their critical thermal max.
As was discussed by Jules, in image 1, you can see that the ant we worked with, P. imparis. And as for the data, you can see here in figure 1 that there was no significant difference between the CT max means of the 2 time points, given the p-value of 0.46. And as for the recovery rate of P. imparis, that can be seen in figure 2. There was also no significant difference between those that recovered and those that died from the CT max with its p-value of 0.67. And to conclude our presentation, the insignificance of our p-value revealed that the thermal tolerance of P. imparis does not necessarily change between the months of March and April. However, due to the pandemic, our data collection was more limited than we had planned. It would be interesting to see if the lack of thermal modification persists in this urban population because rural populations have demonstrated this ability. We also plan to continue our analysis of the recovery of this species after reaching their CT max. P. imparis may be less able to recover from reaching their CT max as they rarely experience this level of heat during their seasonal cycle. Overall, we have more data collection ahead of us before we can make any strong conclusions, but we are able to demonstrate proof of concept and will continue to pursue questions about thermal tolerance in the winter ant. We would like to thank the College of Mount St. Vincent for allowing us to utilize their lab resources and also Dr. Haney for allowing us to participate in his research. Thank you all for watching and hope you have a great day.